friends, welcome to our channel END. In our today's class, we will be taking a group of order P and GCD of P, N is 1. Then I can say that G is generated by x power n. We have already seen in class and I have provided that link in the description box. You can refer to it. And order of G I have taken as 12 and I have written the generators of it to be G is equal to x, x power 5, x power 7 and x power 11. That is G is generated by x power 5, x power 7 and x power 11. So, to make it clear, I'll explain only for the generator of x. How x generates the whole group G. X. First of all, I am going to find the order of this generator of x. That is, since x power 12, order of G is 12, x power 12 is E. So, x power anything I can write so that I will get E mod 12. That is, the power of x has to be multiple of 12 or 12. X power 12, I can write it as x power 24. X power 36, it goes on, but I am going to take only the minimum first. I cannot go, I'm not going to take the next one or the next one, the minimum first, so that order of x is equal to 12 here. Since the order of this x is equal to 12 and order of G is equal to 12, G is generated by x. Similarly, if you take x power 5 and x power 7, x power 11, all these orders are going to be 12. That is equal to order of G. So, if you have found the similarities between this 12 and power of x, you will come to know that GCD of 12 and power of x, that is 1. The power of generator is 12. GCD of 12 and 5, which is, it is 1. So GCD of 12 and 7 is 1. So GCD of 12 and 11 is again 1. So it satisfies this condition P, that is the order of G, that is 12 is equal to x power n, which is 1. 12 and here n is 5. 12 here and n is 7 and 11. So we have proved it that if the group, there exists a group of order P and GCD of this P and the power of x is 1, then G is equal to x power n. That is, x power n generates the whole group G. Similarly here, x generates the whole group G, x power 5 also generates the whole group G.